And good morning, everybody, and welcome to episode 38 of MakerBot Chats. My name is Felipe, as always. Kind of an interesting setup today. We're going to be talking about carbon fiber and metal. So how do we mix them? What are some applications that have found? General implications for the materials. Essentially, how do they interface? What are the things that you need to consider? Specifically, I would say it revolves around tolerances. But yeah, it's going to be an interesting one. I've got, if I switch over to my camera, secondary camera here, I've got this set up here to test out some of the parts that probably you've seen in the past in previous episodes. Specifically, we'll be talking about the gripper, well, of course, the extruder that I've been using to print metal with, and then a couple of new ones. I printed out a wrench. This is a wrench for my bicycle. My bicycle uses a 15mm lock. Well, not lock, to secure the wheel in place, and traditionally I would use this specific wrench, rather massive, to remove it and to secure it. However, by combining carbon fiber and the metal part, I was able to sort of reduce a lot the weight. I'll be talking about that too, and then also the upcoming project that I'm working on, which is essentially replacing now the 8mm hex wrench. This is my multi-tool that I use on the bike as well. And how does that, how to recreate this one for another metal part that will work in a similar way than that of the wrench. Let's get started by just generally describing some of these components, right? As we've said in the past, with Method you're going to be able to print with multiple materials, yeah? Right? So we've talked about carbon fiber for a while. We started talking about metals as well. But the idea is to be able to be jumping back and forth, right? What we're looking at is a platform that enables you to have that flexibility to decide whether or not you want to use one material or the other. And more important than that, to be able to have that flexibility in the same part, right? So we've shown this in the past, which is essentially a robotic gripper that I had worked for the latter part of the year. And the goal here was to make some of the components metallic, but not all of it. Why not all of it? Because if I had made the whole assembly metallic, then these would be rather heavy, right? It would be really hard for any robot to actually hold it, because already, and that's where the scale comes in here. I'll be using grams. If you have any questions, as always, Alejandra's in the back, the back of YouTube, collecting all of the questions. Post them on the chat window. If you're looking at the recording version of this, post them in the comment section below. I will be sure to answer those. But the reason why I have the scale here is because, well, I want to show you the implications of having multiple materials here. So this half, let's call it half of the assembly, which contains the main connecting piece and the first half section of the fingers, is going to come at 146 grams, right? The grip teeth, these two parts, are already about 130 grams, right? So just half, well, not even half the section, but let's call it a third of that assembly is carrying almost half the weight. And that's where it's really important to be able to combine materials and get the most out of each of the each material, right? With carbon fiber, you get incredible rigidity, incredible weight, meaning it's a really light material. So the whole assembly, it's 277, just the teeth 130, and just the carbon part plus the bolts there, 143 grams, right? So the idea is to create parts that are going to benefit the most from each material. In this case, with my gripper here, only the interfacing elements, so only the teeth or only the tips of these fingers are what needs to withstand the most sort of weight, abrasion, the section of the part that will actually interface the most with anything that could damage the assembly itself. The rest of it, I could do better by having a lighter material, right? Originally, I had printed this gripper all in carbon. The idea here is that, well, if you wanted something that could withstand higher temperatures, higher loads, maybe you just want to change that tip component of the assembly and keep the rest of it lightweight, right? Essentially getting the best of both worlds. You're getting your carbon component, your carbon part, but also having that metal tip that will be able to withstand higher temperatures, that will be able to withstand higher loads. Now, in order to interface these parts in, first of all, the first thing that you need to consider is the scaling, well, not scaling, the shrinkage that will happen when the metal is sintered, right? This is my green part, so this is a part as it comes out of the machine, of the 3D printer. It's kind of got this, as I've said it before, it's kind of feels a little bit like clay or similar to clay. And as soon as you get it back from the sintering facility, after it's been debinded and sintered, the part will scale down considerably. It scales down about 20%, and let's see what that specifically means. And also, it's not an even scaling, so it's going to scale down about 20% in X, about 20% in Y, and about 26% in Z. The reason for that is that the weight of the part itself is going to bring the part down a little bit more than the shrinkage that's happening in the X and Y plane. What that means is that I start with a part. In this case, I'm going to measure out the neck of the part. That's about, trying to get you guys to see it, 12.15 millimeters. And I end up with a part that's about 10 millimeters, right? So I had to do that sort of extra calculation. I actually scaled up my part by 20% before printing it, so that I could compensate for that shrinkage rate. Now, I wanted my final part to be 10 millimeters, therefore the 20% extra, that's the 12 millimeters that I ended up printing my part at. And after that, it's all about just matching it with your carbon fiber part. Overall, I would say it's a better idea to first get your sinter parts back, make sure that they have a specific dimension, and just make any adjustments before you print your carbon fiber part, just to be sure, right? Some of the parts will shrink unevenly. We'll talk about that a little bit more with the wrench itself. But yeah, I would say complete the assembly, make sure that you're happy with the result in CAD, print your metal parts, sinter them, and once you have them back, make any adjustments that might be needed in your carbon fiber section, right? In this case, I just added a little bit more tolerance. I made it a little bit looser here. So as I said, my end part is about, let's actually measure it, the exact amount. So my part, here we go. The height of it is about 10 millimeters, so 9.95 millimeters. And the receiving end here of my carbon fiber is 10.10. So I left 100 microns of offset here. The reason for that, I wanted to have not exactly a loose fit, but not also making it super tight, so that it would be fairly hard for me to get them in and out. That's another thing important thing to consider, right? Tolerances. No matter the system that you use, no matter which material that you're using, you will have to adhere to certain tolerances. In the case of carbon fiber, I would say, generally speaking, for tight tolerances, you're talking about 50 to 100 microns, like what I have here. Anything looser than that, that means your part is going to wiggle. Sometimes that's needed. Sometimes you need a little bit more room, more margin of error. And with metal, I would go higher, all the way to about 400 microns, for any printed part. Why? Because of that shrinkage. The shrinkage is going to be uneven, and the best way to manage that uneven shrinkage rate is going to be to have a higher tolerance that is able to accommodate for that shrinkage happening. So about 400 microns in your metal parts, and actually in the green part itself, and about 100 microns, 50 microns, depending on how tight you want the tolerance to be on your carbon part, right? So this is part one, pretty straightforward. We've talked about it in the past. I'm going to go ahead and bring part two, which is a new one, and I'm really excited about that one because I'm essentially trying to replace some, effectively some bike tools. This would be the same with any other type of tool. In this case, this is what I had at hand, and a small project that I wanted to take on. This is my traditional 15 millimeter. Well, it's actually 15 and 9/16, 15 millimeters or 9/16 on the other side for imperial nuts, right? And what this does is actually release the back nut of my bike wheel. I'll have a video of that. I'll bring it in a second. but it's rather, a rather heavy tool, right? It's all made out of essentially black steel, right? And it's just covered with this plastic handle. And if I weigh it here, it comes out at about 334 grams. Moving that into ounces, so about close to 12 ounces, right? However, I wanted to print a similar part that would be much lighter, and I wanted to see like if it actually was able to replace the part. So what I made here, if I bring it closer to the camera, is I just printed the interfacing component, so this center area of my part in metal, and then the wrench itself, I printed it out of carbon fiber for the same reason. I wanted to save weight, I wanted to create something a little bit lighter, but that could, still offer me that sort of extra lever. It's not as long as the original one, right? I could make it longer, but a proper lever to remove my nut in my bike. You'll see the video in a second. And when I weigh it out, that's about 3.4 ounces. So roughly 25% of the weight. And more important than that, let's jump here to my video, is that it's actually able to perform the same function. So this is a previous, a video that I just shot on my bike here. I just basically put it upside down and was removing the nut, and then I was tying it up again. So you can see how I essentially first just pull out on the chain and then take my tool. I'll come in a second. So here I'm just manually tightening those nuts before I do the final pull with my my tool. So there it is. Once I'm happy with the chain itself, I'll just put in my tool and, essentially performing that same job. So here we go, like exerting quite an amount, a high amount of force. It's going to play again, so you can see tightening up the chain, tightening up the nut just manually, and then taking my tool here and just doing the final actual tightening of the nut, right? And that's all that I need. Now this tool probably wouldn't be like my ultimate go-to tool, but it's much better, like it's a much better option if I'm on the road, right? So that's what I'm creating here. I'm creating options for myself by combining the different materials. So I'll jump back here to my original view, right? So this tool, it's impossible for me to carry it while on the road. I wouldn't want to take it with me because it's just super heavy, super big, super kind of a big nuance to carry around. However, this one, it's much easier. And the idea here is kind of to have those two heads. So what I'm doing as well is I'm adding here an 8mm hex nut. So this is what this is. This is already printed in the green metal part. It's my green metal part, which is going to go in here. Of course, it has not been sintered, so there, it's not fitting there just yet. But the idea here is to have a sort of multi-tool where the nut tool here is what allows me to, remove my wheel. It's my wheel nut. And this tool right here is what allows me to remove my pedals. That's another interesting and important thing to do when you're, fixing your bike or when you're trying to travel with your bike. And the handle itself is made out of carbon fiber. So getting the best of both worlds, super stiff material for the handle itself that allows me to exert that amount of force, but the interfacing element, the part that's going to be, or the component that's going to be subjected to the most force, is printed out in metal, sintered, and essentially allows me to get the job done in the same way that this massive black steel tool does, while saving me a lot of weight. It's saving me, as I said, like 70% of the weight just by printing it in mostly carbon fiber and having that final component be the metallic one. And that's the idea, and that's what we're trying to create, with the platform. It's how can you get the most out of each material, and when doing so, that also means how can you interface and mix and match those materials to sort of get, let me jump back here, to get the best results. I'll play the video one more time while I read some of your guys' questions. I want to keep it simple today, but essentially, that's a general idea, right? How do you mix the materials and get the most out of each of them while having something that performs, that delivers, and using the same platform, right? So all of these components were printed on the same printer, the Method X, and essentially that's the beauty of it. That's the flexibility of the platform. I'm able to jump back between carbon fiber, metal parts, and back into ABS if I wanted to, just by either swapping the extruder, swapping the material, depending what the specific case is. I'm going to be jumping here, going back to my main view, to my Q&A, and let's see some of the questions that are coming in. Instead of welding, can I use 3D printed parts to connect other parts? Yes. So it all depends on the result that you're looking for, right? In this case, that's what I'm doing here. So my nut, if I, do I have my macro lens somewhere here? Yep. I'll just plug my lens and show you guys. So what I'm doing here to interface these two parts is creating, so this is kind of like my negative area on my wrench, right? It has these three little notches that will interface, so this is my green part, that will interface with my green part eventually, you know. Those three notches, you know, are mainly what keeps my metal component in place. So yeah, you can definitely interface different components without welding them. If you're talking about metal on metal, that's also possible. You just need to create that same assembly. In this case, what I'm proving is just that mix and match of carbon fiber, that's a black part, and the metal shiny steel part. Let's see. Question, where can we get 360L? Sorry, let me remove the macro lens. Where can we get 360L debinded and sintered in the UK? Actually, that's a great question. We saw that it's just coming in from the chat. We have a number of resellers there. If you send me an email at felipe@makerbot.com, we are actually in the process of defining, you know, what's the best reseller that you guys can use out there. One of our previous case studies, specifically, I don't know if you're familiar with the the Dakar case study. So BRX, you know, an automotive company based out of the UK, actually is looking to do that, and you know, we are in the process of qualifying the proper vendor for 316L. But 316L is, you know, a standard material sold by BASF. So any reseller that you can find there that offers 316L should be able to cover that. If you send us an email, we'll also be sure to put you in contact with them. Let's see, is it possible to join carbon and metal parts in a cost-effective way? Well, I would say this is it, right? It's just, you're essentially creating an assembly. It depends on, you know, whether you need bolts. So that's, I'm missing the little bolt here, but essentially having a part that nests and it's just connected via a bolt, a part that is just a press fit, which is what this wrench is. So it's definitely possible. You know, it's kind of free, I would say, maybe, and it's all about the geometry that you're using. How does carbon fiber composites resist corrosion? Well, the carbon fiber doesn't really corrode, right? It will have some changes if exposed to humidity, but it's, you know, only metals corrode. They don't oxidize. Nylon and carbon fiber, they don't react to the oxygen present in the atmosphere, but they will change properties if you're like soaking them in water, if you're exposing it to any sort of liquids. For that, you know, if you're having an application that requires exposure to the elements or exposure to certain chemicals, I would say look into perhaps just standard nylon, maybe ASA, maybe PETG, depending on what the application is. What's the best resin to use with carbon fiber? Well, that would be a question to ask if you were actually not printing carbon fiber, but actually having, you know, layered carbon fiber. And in our case, the beauty of printing with carbon fiber with a method is that you're not using any resins. You're just using the pure material that has that substrate of nylon along with the nylon, the carbon fiber, you know, shredded carbon fiber. So there's no resin, there's no really issues there, and nothing to worry about in having to actually select a resin for carbon fiber. If you're using, you know, a layered approach, meaning, you know, kind of like how bicycles are done, how tennis rackets are done, then you do need a resin, but that's a much more cumbersome process, and it's not something we will be covering here. What's a workflow I can expect when working with metal filament? Okay, the simplest explanation would be you print a part, you send them out to sintering and debinding, and you get them back. That's about it, right? Overall, it takes about between a week and 2 weeks to get your parts back. In my case, in my experience, it's been about 5 days turnaround time. So I will send my parts out on a Friday. I get the parts back on a Tuesday or Wednesday. Fairly straightforward and really easy. I mean, I haven't had any issues. What design guidelines should I keep in mind for metal parts? So definitely, something that we need to cover more in depth in the future. Overall, I would say start with the scaling issue, meaning those 20% and 26% shrinkage rates, 20% in X and Y, 26% in Z, and get going from there. Also consider you won't be able to use any supports. However, even without supports, you can print really complex parts, which is kind of like, this is the example that I got here. This is a self-supporting structure. It hasn't been sintered yet, right? But I'm just testing out the limits of the material itself. As long as you're not using supports, as long as you're considering that shrinkage rate, that's a good place to start working with metal. What are some common applications for these materials? Well, I would say, metal, awesome, specifically because of the sizes that you can get. As we've talked, here in the past, most sintering facilities will offer you or will be limited by about 100 millimeter cube box. So you're talking about parts that are about the size of a fist. That means, fairly small parts that interface with anything, that's abrasive or that need to be super strong. That's where I think these parts come in as really good examples, whether, it's just the tip of a gripper, just the interfacing component of a wrench here, or, a hex key. That's what I'm doing here. Those are the types of parts that you would be using with metal. With carbon fiber, there's a lot of applications, and this is an interesting one as well that I'm working on. This is also a replacement pedal for a bike, so I printed it out in carbon fiber. I haven't tested it out. I have yet to connect it to the bike. But yeah, essentially anything that you want to reduce the weight, and the original pedal here that I'm using is kind of a steel/nylon assembly. It's rather heavy, but with the carbon fiber part, I have a lot of control over the resolution, a lot of control over the tolerances, really complex parts, and it's just essentially interfacing with the spindle. So the spindle is not something that is 3D printed, that's something that you get off the shelf. So a lot of really interesting applications. I'm sure we'll be talking about this guy a lot more in the future, but it all depends. And I think that's where nylon carbon fiber, incredibly flexible material. I really like it a lot. I've been having a blast with it. And in future episodes of Chats, I think we're going to be doing more of the carbon fiber, nylon carbon fiber examples. So I think with that, we've covered most of the questions. And as always, thank you guys so much for watching. If you have any more questions, do reach out. Hello at MakerBot, Felipe at MakerBot, or at MakerBot in any one of our social media accounts. For people in the UK asking about BASF, do send us an email and we'll put you in contact with the relevant supplier. But yeah, for now, that's about it. So thank you guys so much for watching. And as always, happy printing. Bye.